Guys, in this example, we're going to be looking at two graphs. So this is example 5. We're asked to sketch the graph of each function. So when I sketch a graph, I need two things. I need the vertical asymptote and I need the anchor point. And to do those two things, not too hard. So we'll start off with the asymptote. We're going to set what is in the equal sign equal to 0. So x plus 3 equals 0 because we cannot take the log of 0. So we'll solve this. So subtract 3 from both sides, or just do the opposite, x equals -3. So let's go ahead and plot that graph, or that asymptote, going through x equals -3. Okay, then the anchor point. We're going to set x plus 3 equal to 1, because when I have the log of 1, the log of 1 any base is 0. So we're going to solve for x. So x equals -2. Well, if the log is 0, then all we have left is this plus 3, and that must mean that y is 3. So I'm going to have this point at -2, 3. So we have -2 up to 3. So this is going to be that anchor point. This is going to be that moment when it changes directions. Now, what to do with that 5? So because the base is greater than 1, we have logarithmic growth. Okay, so just like with exponential growth, when the base is more than 1, it is growing. So it's going to be starting out low and going high. So we're going to start out at the bottom of the graph next to the asymptote. Then we're going to turn directions at the anchor point and go up from there. And that's what you got. Okay, that's how easy it is. So let's look at part B. The big difference on part B, look at that base. The base is 1/2, so we're going to see logarithmic decay. But same first steps. We'll set x minus 1 equal to 0. We'll add 1 to both sides. X equals 1. Okay, so let's go ahead and draw that vertical asymptote at x equals 1. Okay, and then let's set x minus 1 equal to 1, because if I have the log of 1, the log of 1 any base is 0. So add 1 to both sides, and x equals 2. So if the log is 0, then that means that I must only have -3 left over. So y is -3. So my anchor point is going to be at 2, -3. So we'll go over to 2, down to -3, put our anchor point there. That's where the graph is going to change directions. And again, going back to that base, the base is 1/2, so that means it's going to be logarithmic decay. So we're going to start high and go down. So we'll change directions at that anchor point. And I should say, I should see the anchor point somewhere, either on the graph or on the side. So I'm going to put it on the graph as well. So 2, -3. And if I go back to the other one, I can put the anchor point on there as well. So -2, 3. So guys, that's it. That's how you graph exponential or logarithmic functions. If you guys have any questions, let me know.